anyhow, so we have our overall design equation. Q is U AS delta T log mean. And we can frame this in the context of a resistance network. This U we can write as, I'm going to break out of the notes for a second. U is HIAI anyhow. I guess I don't need the notes as much as I thought I did, but I'll open this. U is HIAI, so it's the inner heat transfer coefficient or outer heat transfer coefficient. And what this means is we have a shell side, we have a tube side, and in a real system there is a pipe that separates the shell and the tube. This pipe has a measurable thickness. And so the outer area, if we calculate the outer area of the pipe, is different than the inner area of the pipe. If we have multiple runs, we can sum up all the inner and outer areas. But then the sum of all the inner areas will be much less than the sum of all the outer areas. So that's what this overall heat transfer coefficient, U, is the overall heat transfer coefficient. And you get there by taking a resistance network, and you see HIAI, you have L over KA is the thickness, or if this is a circular pipe, we'd have the natural log of the outer radius over the inner radius over 2 pi KL. And then you have 1 over HIAI. And if we have a steady state system, a heat exchanger operating in steady state, we have a constant flow through these resistors, and you can derive this overall heat transfer coefficient from a resistance network. All right, so where are we at?